Hi guys, welcome to Creativa Solutions past paper support session. My name is Anthony and I'm going to be taking you through another past paper for DSC1630. Today I'm going to be looking at the October-November 2014 exam. Right, so again, as always, just to start off, we've got a third-party disclaimer. The material in this video may include information, products or services by third parties. Third-party material comprises of the products and opinions expressed by the owners. As such, I do not assume responsibility or liability for any third-party materials or opinions. I cannot guarantee the accuracy of the information contained in the third-party material. Presentation of such third-party material is simply used as a tool for assisting viewers with answering questions for educational purposes. All trademarks appearing in this guide are the property of their respective owners. Right guys, so the video that you're watching is going to show you exactly how to approach the exam paper and what to look out for and how to answer the questions. For more content and resources, please visit the website www.creativasolutions.com. Good luck with your studies. Follow us on Twitter at creativa_s and watch our YouTube channel for all the different support material. Right, so guys, let's get started with the past paper. Let's have a look at DSC1630, October-November 2014, Introductory Financial Mathematics. Obviously the exam's out of 2 hours, okay, and it's a 100-mark question, right? It is a multiple choice question. There are 30 questions to answer. Remember, you are definitely going to need a financial calculator, so make sure you've either got the Casio, the Sharp, or the HP. Alright guys, so if we look at the first question 1, right, let's get started with that one. Okay, the question says the present value of a loan of $12,000 due in 5 years time at a simple discount of 15% per annum is equal to. Right, that word should be standing out for you as the student writing the exam, okay, because that tells you what equation to use. Right, so I'm going to go to my formula sheet. Okay, UNISA does give you a formula sheet in the exam, and you're going to pull through the right equation that you're going to be utilizing. Right, so we're obviously looking at simple discount. Okay, so simple discount is that equation over there. Okay, I take that equation through to my workings. I write it down, I then substitute and solve. Right, so if I go back to the question, I'm going to take values from the question. Okay, they said in the question that the present value of the loan is equal to. Okay, so that's what you're trying to find out. Right, so we know what the loan is equal to, 12,000. Okay, we know what the discount interest is, and we know what the time is. Alright, so 1 minus the 15%, okay, times the 5 years. Alright, so if I plug that into my calculator, okay, and I ask the calculator for an answer, right, the calculator is going to give me an amount of 3,000. Okay, 3,000 is the present value of that particular loan. Right, question number 2 says, on 29 March 2014, A deposited 3,500 into a savings account. The simple interest rate agreed upon was that 7.5% per year. The accumulated amount in savings account on 1st October. Okay, for me and for you, what should be standing out is this. Okay, dates. When you see dates, you know you're going to have to do what? Calculate the days. Right, and I'm also looking at this, simple interest rate. Okay, so now I know exactly what formula to use. Again, I go to my formula sheet and I take the correct equation. Okay, why do I use that one? Because the question said simple interest. Okay, so I write down the equation, I then substitute and I solve. Okay, remember I'm going to need the dates though. So I'm going to have to count the number of days from 29 March to 10 October. Okay, what I suggest you guys do is try to do that before I give you the answer. Okay, so maybe pause the video here, go to this particular table of values in terms of days, look for the right dates, take the one amount minus the other and see if you get the same in as I do when we actually do the calculation. Right, so obviously we're using that equation. I've got the information in the question. They deposited 3,500 into a savings account and there's the interest rate. Okay, so now it's just a matter of substituting. Okay, so I'm looking for this. Alright, so this was deposited, okay, into the savings account. So if you deposited into a savings account, that would have been the present value. Okay, so your S or your future value, right, is going to equal the 12,000 open brackets, the 1 plus the rate, which in this case was 0.075. Okay, open bracket, and I need to put my time. Right, if you count the number of days right from those two dates, okay, 29 March to 10 October, right, you should be getting a total number of days equaling 195. Right, divided by 365 days in a year, close that bracket, and ask the calculator to give you an answer. Right, so I'm going to substitute all of that into my calculator. Okay, and what does the answer come out to? 12,480. Okay, 12,480 is what? The future value. Okay, so in this particular question, okay, I'm going with option. Hold on, I've put in 12,000. That's a mistake. Sorry, I'm thinking about question 1. Okay, question 1 had the 12,000. Right, this was 3,500. Okay, so that's an error there. There should be 3,500. Okay, and that should be 3,500. Right, that's better. Okay, that answer is there. Okay, option number 2. Alright, so just be careful. Don't make silly mistakes like I've done there. I've substituted the wrong amount in. Okay, clearly question 2 says 3,500 is deposited. Okay, so please make sure you're using the correct figures. Okay, question 3. If someone borrows 2,000 at a simple interest, at an 8% simple interest per annum now, the amount that the individual will receive at the beginning of the 8th year. Okay, so beginning of the 8th year meaning, right, from now till later. Okay, if it's beginning of the 8th year, it's end of the 7th year. Okay, so we're going to have to use that same equation that we used here. Okay, but I'm going to be substituting in a different n than the one that we said in the question. Why? Because I'm looking for the future value. Alright, so 2,000 at 1 plus the 0.8 bracket 7 years. Okay, remember I'm using 7 years and not 8 because they said beginning of the 8th year. Right, so beginning of the 8th year would have been end of the 7th. Okay, so if I plug that into my calculator, calculator is going to give me an answer of 3120. Okay, 3120. Right, question number 4. 4 says the accumulated amount after 6 years if that is invested at 17% compounded continuously. Okay, again, keyword in the question, continuous compounding. Go to a formula sheet and take the correct equation. There's the equation that I need for continuous compounding. Write that down and then substitute. Okay, remember the question here said that the accumulated amount after 6 years if that amount is invested. Okay, so S or FV is going to be the amount that you're investing, okay, the 6,500, all right, to the power, or E to the power open bracket. Your compound interest in this case was 17% compounded continuously, right, for a total number of 6 years. Okay, if you take that and you type that into your scientific calculator, okay, you're going to get an answer of 18,025. Right, and that's the answer for question 4. Question 4, 1825. Alright guys, question number 5. Okay, when you see a question like this, it looks quite long. Right, good idea would be to maybe draw a little sketch, okay, or a diagram to try and identify all the different variables. Okay, sometimes it is very useful, okay, other times it's not necessary. Okay, so it all depends on you. Okay, remember, your niece is not going to mark your workings, they're going to mark your answer. Okay, so make sure you can get to the right answer as quickly and easily as you can. Right, drawing a diagram can help. Right, so having received a huge inheritance, Karan's parents wish to establish a trust for his university education. If they need an estimated 70,000 15 years from now, how much should they set aside in the trust now? Okay, so what are they trying to work out? They're trying to work out the present value. Okay, they know what the future value is going to be and they know what the interest is. Okay, just be careful with this. Compounded every 3 months. If it's compounded every 3 months, remember, every 3 months means 4 times a year. So if there's 4 times a year, it's going to be quarters, okay, which is I4. Right, so in this particular question, Okay, I4 is given in the question. Okay, 18.5%. Right, so this is actually not a very difficult question. As long as you can identify the correct variables, you'll be able to get the right answer. Okay, so obviously my future value is going to be the 70,000. Okay, I've got an I4 of 18.5 divided by 4. Okay, what else do I have? Well, in the question they also gave me the number of years, 15 years from now. Okay, so n equals 15 times 4. Okay, and I'm working out PV. Alright, so if you solve for PV on your calculator, your financial calculator, you're going to get 4644,82. Alright, 8295. Alright, and that is option number 1. Alright, so simple enough, just identify the variables. Okay, no need to draw a sketch. You could have if you wanted to. It would have been a very basic diagram, but it is very useful as well. Alright, question 6 and 7 relates to the following. You've got cash flows for plain sailing rowing club. Right, money can be borrowed at that percent, and investment can earn that percent. Okay, you've got years, you've got cash flows. You can see you've got positive and you've got negative cash flows. Alright, so you know this is probably going to be an MIRR type question. Okay, when you see those two together, okay, other negatives appearing over the life of the project, you're going to have to modify the IRR. Okay, so 6 is asking you for the future value of the cash inflows. Okay, so what am I going to do? Well, I'm going to use the financial calculator and I'm only going to put in the inflows, i.e. the positive amounts in my calculator. Okay, so let's do that working. Question 6. Question 6 is a can you use the calculator question. Right, so I'm going to need all the cash flows for those 10 years. Okay, obviously the year that I don't have here, we would assume there's a zero amount, okay, or no cash flow. Right, so nothing here, nothing there. Right, in year 2 we have plus 5,000. Year 3 a negative, year 4 a negative. Then the next one is plus 25 at year 7. Alright, then we've got plus 15 at year 8. Right, we've got zeros for all the rest. Okay, and then what I'm going to do, I'm going to substitute in. Okay, so insert the I. Okay, the I in this particular case, right, is going to be the 17.5%. Okay, given the question, that's the amount of money that will be borrowed. Okay, and I then solve. Okay, you can work out net future value, right, on the Casio, right, but on the Sharp and HP, okay, first work out the net present value, then take this answer forward to the end to get the net future value. Okay, so on the Casio you can do it in one step, right? So which is what I did on my calculator, right? When I work out the net future value, I got an answer of 79,431,8044. Right, if you did it using the Sharp or the HP, first calculate net present value, which comes out to 15,834,92, then move forward to the end. Okay, net future value equals same answer, 79,431,80. Right, so it doesn't matter how you do it, as long as you're getting the right answer, either or, it makes no difference. Okay, you're going to be choosing option number 79484. Well, you can't actually choose the exact answer, you'd have to round off to the nearest rand. Okay, for question 6, I'd be going with option 4. Not option 4. Question 6. Question 6 was looking at, this was the NPV. Question 5 actually. Right. Yeah, 5 is the right answer. Okay, 5 is the correct answer. Net future net future value. Alright, question 7. If the present value of the cash outflows equals that, then the modified IRR equals. Okay, so you know modified IRR is given in the formula sheet. Okay, take that through to your working. Okay, and then substitute and solve. Right, remember we've worked out an amount, okay, in terms of future values of the inflows, right, which is C above, right, and then your present value of the outflows was given in the question, okay, and that was given as 24736. Alright, so I'm going to insert all of that into this equation over there, okay, and once I've inserted all of that, put the 1 over the n, okay, minus 1, obviously n here is 10, there's 10 years, right, and then solve for MIRR. Right, and MIR in this question comes out to 12.3741%. Right, which is option number 3. Right, question 8, guys. You've got Togo invested 50 in a fund that earned that interest compound half yearly. She wants to receive 3 equal amounts of money in 2, 6, and 8 years' time. The amount that she will receive at year 6 equals. Right, so when you see a question like this, you know you're going to have to draw up a timeline, right, purely because you're working out a missing figure. Okay, so if I draw up a timeline, I'm going to need those dates, okay, or those time periods. Okay, so T0 is where I start, okay, then we'll have T2, then we'll have T6, and then we'll have T8. Okay, that came out of the information from the question. Right, they told you that there was 50,000 Rand here. Okay, and there's going to be an amount here, X. There's going to be an amount here, X. And there's going to be an amount there, X. Remember, all 3 amounts are equal. Okay, so X, X, and X. Right, so we're going to have to look at the amount that she invested and the amount that's going to be provided. Okay, so obviously the amount invested, future payouts. Okay, everything needs to be at the same point in time. Alright, so what I've chosen to do with this particular question is I've chosen to take back all of the X's, okay, or the payments. Alright, so I'm going to be using a formula, right, to discount all of those amounts back in time, to take them back in time. Okay, remember all the amounts need to be at the same point in time for you to evaluate the value. Alright, so what am I going to write here? I'm going to write down obviously the 50,000. Okay, and the 50,000 is going to equal the X. That's going to be discounted back at 1 plus the interest rate, which in this case was 6%, close bracket to the power. How many times do I move it back? I move it back 4. Okay, why 4? Right, well, if you look at the question, they said compounded half yearly, right, and they said in 2 years' time. Right, so this is obviously 2 years, and years. Alright, and that's why I need to multiply this by 2 to get half years. And that's where that minus 4 comes from. Okay, guys, plus. Right, the next amount, so at T6, I'm going to be discounting that 12 periods. Okay, and T8, I'm going to be discounting 16 periods. Right, so now you've got X's and you've got all those amounts. Okay, obviously we need to work out what those figures are separately. Okay, so a lot of mathematics here. Okay, and those are what all those figures are, right, as a number. Okay, I've taken those brackets there and I've worked out a coefficient for x. Right, then you've just got to work out, solve for x now. Okay, so add up all the amounts and then take the 50,000 divided by that. Okay, it gives you an answer of 29,713,98547. Right, so x is that answer, which in this case, option number 3. Okay. Alright, 9 talks about Graham took out an annuity with annual payments of that increases each year by that. Okay, when I see this increases by each year, I know this is a growing annuity. Okay, so I take the formula for a growing or increasing annuity, I write down the equation, and I then calculate. Okay, it's as simple as that. Insert your variables. R here 6.5, Q here 1700, I here 10%, N here 20. Right, so the first bit, this bit over here, I'm going to work out separately as part of the annuity. Okay, so I'm going to be looking at this as a separate calculation. Right, and this annuity answer comes out to 1345962,488. Okay, then I less the 20 times the 1700 divided by the 0.10, okay, which in this case was the 340000, okay, and the final answer is 1005962,488. Right, and that's how I would do that. Okay, remember, I'm getting the annuity answer first, okay, by plugging in that information. Okay, so the annuity comes from a payment, right, of brackets the 6.5 plus the 1700 divided by the 0.10, close bracket. Okay, obviously the n in this particular question was 20, right, and the I in this particular question was 10%. Okay, so coming back to the question, right, you can see it's an annual payment, right, and the rate was per annum, so everything is in annum, so you don't have to convert anything, right, and you have to just solve and then subtract, okay, the n times the q over the I. Alright guys, that was question number 9. Alright, question 10. You are quoted a continuous compounding rate of that, the equivalent nominal rate, okay, compound every 6 months, right? So here they're wanting the nominal rate, okay, which in this case is what you're starting out with first before you do any conversions to the effective. Right, so I have been given a formula sheet. I'm going to be using this equation for the nominal interest. Okay, so I take that equation and I write it down, and I then substitute and solve. Okay, obviously my m in this particular question would be 2. Why 2? Well, if you look at the question, they told you this is compounded every 6 months. Right, remember, it's continuous compounding. We just read that. We know we're going to be converting this to I2. Okay, every 6 months, so twice a year. Right, so your m value here is 2. Okay, your c value here is the rate being the 0.1906,204. Right, your m is obviously 2. Then you minus the 1, close that bracket, and solve, right? And your final answer is 20, 1, 2, 3, 4, 5 zeros, right? So 20% if I round off. Okay, what is that? That's the nominal rates. Alright, question 11. Savings account pays interest at that percentage semi-annual. Remember, if it's semi-annual, we know that's half yearly. Right, the amount that should be deposited now, so that 250 can be withdrawn at the end of every 6 months. Right, so that's important. At the end of every 6 months, half yearly for the next 10 years. Okay, so you just need to identify the variables and solve. Alright, so with 10, payment 250, I2 is the 5%, divide by 2. Your N here would be 10 times 2. And you're solving for present value. Right, and if I solve for my present value, I'm going to get an answer of 3897,29. Right, so the answer for question 11, option number 3. Okay guys, question number 12. The effective interest rate equivalent to a continuous rate. Okay, so now we're looking at the effective annual interest rate compared to the continuous. So again, go to the formula sheet. If it's effective, it'll be a I to infinity, right? Because it's never ever going to end, because this is continuous compounding, right? So you've got very small periods, okay, that are going to be running over a period of time. Alright, so I should have put in the N. Okay, not the N, the C. Alright, the C in this particular question was given as 17,5%, okay, which is 0,175. Okay, and I'm going to insert that where my C is, and I'm going to solve for J infinity. Alright, J infinity comes out to, this is question 12, option 3. Okay, 19.12%. Right, we know it's going to be a lot bigger than 17.5. Why? Because 17.5 is continuously compounded. So, right, so you're not going to be getting 17.5. You're going to be getting a lot more than 17.5. Right, option 3. Okay, question 13 and 14 both use the following situation. Okay, Ian wants to open a bicycle shop at Buy a Ride complex. Okay, he estimates that he will have 250 available on 16 June for an investment made on 7 September, earning 7.65% compounded on the first day of each month. Okay, that's very important. First day of each month. Right, so you've got two parts to this question. Okay, part 1, which is question 13, says if simple interest is used for the odd periods, compound interest for the full, then the amount that Ian deposited on 7 September equals. Okay, so 7 September is what? It's the 7 September. Where's our 7 September? Okay, there's our 7 September. That's the investment. Okay, so that would have been the future value. Okay, so we're taking things backwards. Alright, so quite a tricky question. Okay, because normally in previous past papers you've been taking things forward. Now we're taking things back. Alright, so I'm working out the dates. Okay, so let's write down the dates, draw a little timeline. Okay, right, and I've got an amount here, future value of 25, okay, 250,000, right, and I'm going to be taking that backwards. Okay, so I need to move things back in time. Obviously I need number of days here. Okay, so again, use your table to count the number of days from 1st June to 16th June. Okay, you're going to get 15 days. Right, 1 September to 1st October, 24 days. Right, so I've got full periods there and I've got odd periods here. Okay, so I've got odd period calculations, right, and compound interest. Right, so how many months from 8 October to 1 June? 8 months. Alright, so we're going to be moving things back in time. Okay, so we're starting forward and we're moving back and then back and then back again. Alright, so step 1 is going to be the discount. Okay, so take that back in time using the simple interest formula. Okay, we saw that earlier. Let's write it down again. Okay, there's a simple interest formula. Alright, so PV equals the 250,000 divided by open brackets 1 plus the rate, which in this case was 0.0765, okay, times the time, which in this case was 15 over 365. Close that bracket equals. Okay, and if I type that into my financial calculator or my scientific, okay, because this is a mathematical type of question, okay, I'm going to get that answer, right? So that's what? That's the amount that I've discounted back in time to 1st of June, okay, beginning of each month. Right, now I'm going to take that amount and I'm going to be discounting that amount back in time. Okay, so discount using compound interest. Okay, I'm obviously going to write my future value. Future value equals n equals 8, I12 equals 7.65 divided by 12. Okay, solve for present value, right? And the present value that you solve for comes out as 236,863,46. Okay, right, and then obviously the second or the last step, actually that was step number 2. Okay, the last step over here, step 3, okay, is to then move it back using simple interest again. Alright, so now I'm going to be taking a future value of this figure, my R in this question was 0.0765, okay, times the time, which in this case was 24 days. Okay, so it was 24 days over 365. Okay, alright, solve for PV. Right, and the P that you get for this question is 2,35677,975. Okay, 2,35667. Exact. Okay, option number 1 for question number 13. Right, 14 is a follow-on. They say if fractional compounding is used for the whole period, then the amount that Ian deposited on 1st September equals. Okay, so again, work out the present value. Right, based on what? Fractional compounding. Okay, so let's work that out. That was 13, this was 14. Okay, so I know what the future value is. 250,000. Okay, I need the number of days, right, from 1st September 2014 to 16 Jan. Okay, so you're going to need a calculator for this. Okay, let's work it out quickly for you. Right, so June, this was 2015, yeah, September to June. Okay, so September 7th, 2014 to June 16, 2015. Right, I get 282 days. Okay, so 282 days. N equals 282 days. Right, divided by 365. Okay, because that's the number of days in a year. Alright, so what rate was I given in the question? I was given 7.65 interest per year. Okay, compound on the first day of each month. So that's I-12. Right, so I-12 is given as 7.65. Okay, which I then need to convert to I-365. Okay, so I-365 will be 1 plus 0.0765 divided by 12, close brackets, to the power, open brackets. This would have been I-12 over 365, close brackets, minus 1 gives me a rate of. Okay, let's check that. Right, so 1 plus 0.0765 divided by 12, close bracket to the power, 12 over 365, close that bracket, minus 1, okay, times 100 gives me a percentage of 0.02894556279%. Okay, and what is that representing? That's representing the I-365. Okay, so I can actually change the N, right, to days because I've got I-365. Right, solve for present value. Right, so that percentage I need to keep. Okay. N was 282. I was the 0.02. Future value is 250,000. Solving for your present value. Right, if you solve for your present value, you're going to get 235,696,36, okay, which is option number 235,696, 235,696. Okay, so 235,696, 696. Okay, well, there's an option here for 679. Okay, 96. All right, and that's 235. Yeah, 235,679. Okay, that could be a typo in the question, perhaps. Okay, in terms of the solution here, because we've used the fractional compounding and we've used the correct dates. Okay, from 2014. To 2015, yeah, so those are the right dates. Okay, so there's a slight error here, perhaps in terms of rounding. Okay, I haven't used any decimals. I've just used the full amount without any rounding, and that's the amount that I've gotten. Okay, so you're definitely going to be going with option number 2 here, right? Providing for 1 or 2 slight rounding misconceptions, perhaps in terms of the working. Okay. Right, in terms of estimates. Alright, so question 15. 15 is looking at what? Okay, IRR. Right, this is use the financial calculator. Cash flow. Okay, your IRR comes out to question 15, option 1. Alright, so you're going to get that particular IRR using those amounts. Just remember the outlay that you insert in your calculator must be negative. Okay, it must be negative and the rest of the amounts positive because they're inflows. Okay, so it's to distinguish between inflows and outflows. Alright, question number 16. Okay, 16 is a bond calculation. You can see by looking at it, and they're asking you to work out the all-in. Okay, so we're looking for what here? Okay, we're looking for the all-in price at settlement date. Okay, so we're going to need to draw a timeline. Alright, so we've got 1st January 2044. Okay, that's this maturity date. Right, so let's draw a timeline. Okay, and I obviously need H and N, not H and N, H and R. Okay, your N here would be the full period. Okay, so your R here, if you work out how many days, you get 24 days. Alright, and if you work out your H, okay, I get 181. Okay, remember we're assuming half yearly. Okay, remember bonds generally pay interest half yearly. Alright, the first step is to get what? The price. At what point? At 11th of the 7th, 2015. Okay, so how many years do I have from that particular point in time to that particular point in time? Well, remember, 11th of the 1st, 2016, okay, would be the next period or coupon after that particular period. Alright, so if I take the 2044 and I minus 2016, I get 28 and a half years. Alright, so those are the number of years that you've got, okay, in this particular question, 28 and a half years. Right, so to work out the price at this particular date, okay, n equals 28,5 years, times that by 2, gives me 57 as my n. Okay, my PV is what I'm going to be solving for, my FV, right, which was given this question. Okay, well, we'd assume that that's 100, okay, because they gave you the bond pricing convention. Okay, your payments here are how much? Coupons 9.9 per year. 9.91. Okay, divide by 2. Alright, that's the payment. Payment, FE and N, you just need an I. Okay, in this particular question, they gave you the yield to maturity 7,47. Alright, solve for present value. Alright, so if I solve for my present value using those variables, okay, the rate was 0.0747. Okay, my N was 57. My payment was 9,91 divided by 2. Right, your future value was 100. Close that bracket and I solve. Okay, I'm going to be getting that answer. Okay, this was divide by 2. Okay, divide by 2. Don't forget to divide that by 2. That's a mistake there. Quickly correct that. Divide by 2. Okay, that's better. Right, 2862. Okay. Alright, now what do? Is this cum or x? Well, it's greater than 10 days, so cum interest. Right, so we add a coupon of 0.91 divided by 2. Okay, which gives us what? Okay, gives us that answer. Alright, then what do I do with that answer? I then take that answer back in time using what? Fractional discounting. Okay, so future value equals that figure there. Okay, n equals fractional discounting 24 days over the 365. Okay, or no, over the 181, because this is half years. Alright, and then I've got the I2, solve for present value. Alright, the rate's 0.0747 divided by 2. Okay, the n here was 24 over 181. The payment here would be 0. The future value was our answer there. Okay, and I get 132,93, option number 5. Okay, option number 5 on the dot. Okay, brilliant. Right, so question 16 answer, option number 5. Okay, 17, you bought a Canon digital camera. Your agreement states that you should indefinitely start paying that amount per month. In terms of the agreement, it's 24 months with applicable interest rate compounded monthly. Okay, what is the original price of the camera? Okay, so all you're going to have to do here is what? Solve. That's all you're going to have to do is solve for the correct price, okay, or the starting amount. Okay, so question 17, we're looking at beginning or end mode here. Well, the question said immediately starts paying. Okay, so if it's immediately starts paying, begin mode. Right, so don't forget to change your calculator to begin mode. 24 months R12 equals the 20,124 divided by 12. Okay, the payment is 1403. Solve for present value. Right, and the present value comes out as option 3. Okay, and that's question 17. Right, let's look at 18, guys. What is 18 focusing on? Okay, stats. When you see a question like this, you've got X and Y, you've got a table. Okay, you know this is probably going to be linear regression. Okay, they tell you already there's a linear, or suppose there's a linear relationship, okay, between the two. Right, so you're going to have to calculate the coefficient correlation, which is what? That's the R. Okay, so use the financial calculator. Or the scientific can also do stats. Solve for R. Okay, if you solve for R for 18, you get option 2. Alright, 19 says quarterly payments that are made into an account compounded monthly. Okay, notice compounded monthly, quarterly payments. There needs to be a conversion. Which stands out more than the other? Definitely the payments. Okay, so payments are per quarter. $7,000 made into savings accounts. Okay, I want I4, I was given I12. Okay, so I4 would equal, open brackets, 1 plus I12. Okay, equals per quarter. Okay, and then I'm going to solve for the accumulated amount, solve for FE. Okay, obviously putting your N. How many years? Accumulated amount after 12 years, so N equals 12 times 4. Okay, solve for future value, and you're going to be getting option number 5. Right, question 20, guys. You can see it's a mathematical type of question where you're going to have to rearrange the formula slightly to get a term that represents the Q. Right, so obviously you're looking at the increasing annuity formula. Right, so let's go get that equation again. And let's write it down. Okay, so this is mathematics. Okay, we're going to have to manipulate this particular equation and to get it looking in the right format. Okay, so I'm going to go back to my working here. Okay, I'm going to write down the equation. Right, so first things first, obviously take this to that side. Okay, this fancy notation over there represents a bracket. Okay, so if I take that to this side, okay, then what I'm going to do, I'm going to have to get rid of the R and the I in the denominator for the Q over I. Okay, so I'm going to have to then move the I across, so it'll be brackets S plus N Q over I over S N I, okay, minus R, right, and then this T here needs to be multiplied by all of this. Okay, all of that needs to be multiplied by T. Okay, so looking at that, let's see which option looks correct. This is question number 20, option number 4. Alright, so yeah, there's the I multiplied by the S. Okay, this would have been, that's minus NQ, so when NQ goes that side it becomes plus. Okay, minus N. Minus N, no. Where is Q? Q is that side. Option 4. Actually, option 4. Option 4 is close, but not correct because there's a minus there. Okay, remember if I multiply this out, it'll be I times this, which is fine. Okay. No, it actually wouldn't be, because that would be the I would be times this NQ. Okay, so 1 times I times NQ would be would actually cancel it out. Okay, so the answer for this particular question would actually be none of the above. Okay, for this particular one. Right, looking at the notation. Okay, taking out an increasing annuity. Right, paying yearly payments that will increase by. Right, we're solving for Q. Okay, remember the SNI is a mathematical bracket. Okay, the bracket's in your formula sheet here actually. Okay, let me show it to you. Here's it over there. Okay, so that fancy notation refers to that bracket. Alright, question 21, guys. Question 21 and 22 relate to the following information. Susan bought a house and made a down payment of 40% on the price of the house. She managed to secure a loan for the remainder for 20 years at 13.5% compounded monthly. Her monthly payment is that amount. What is the down payment? Okay, so we need to solve for the loan amount. Okay, so N is 240. I was 13.5% divided by 12. Payment was given as 7026.92. Solve for PV. PV comes out to 581,999,9558. Okay, remember, what does that represent? That represents 60% of the total house value. Okay, so that's the total cost of the house. So obviously the deposit is the difference. Okay, 388,000. Okay, that's the deposit. Okay. Question 22. The following is an extract from the amortization table. Okay, so that's what we've got there above, and they want to know the value of A. Okay, A, value of A equals, okay, outstanding principal at the beginning of the month. Okay, so the monthly payment, we already know what the monthly payment is. Okay, and we know what the interest due is. Okay, so obviously the difference will be C. Okay, so the monthly payment, let's insert the payment, 7026.92. Okay, the principal repaid would be the difference between those two amounts. Okay, so 7026.92 less 4831.7 equals this amount, 2195.22. Right, and this is what I had after. Okay, so after I've made that 137th payment. Okay, so obviously if I'm looking for A, okay, A is going to be what? Okay, this plus that. Okay, so A comes out to 429484.77, option number 1. Right, question number 23. The balance in this account after 5 years equals. Okay, so after 5 years, Okay, remember this is looking at Mildred depositing 25,000 into an account. Okay, compounded quarterly. After 5 years, the interest rate changes. Right, she deposits an extra 500 every week into this account. The balance of the account after 5 years is. Okay, so first step is to work out what is the balance in the account after 5 years. Alright, so PV equals 25,000. 5 times 4. Okay, 20 quarters. Okay, remember we read that. Here, there's the note, compounded quarterly. Okay, so that's how much you're starting with. Okay, and then I'm solving for the future value after 5 years. With the rate of 9.75 compounded quarterly. Alright, so that's question 23's answer. Question 23's answer was option number, this would be, none of the above. Okay, the answer isn't there. Alright, question 24. I'm then going to be looking at what? A change in interest rate. So she decides to deposit an extra 500 every week, okay, into this account. Okay, so do you agree there's going to be two things here? Okay, there's going to be an amount that she currently has, okay, which is this amount. Okay, that's the PV that she currently has. She's going to contribute more. Okay. The rate has changed to I52, which is 10% divided by 52. Okay, and your N here is going to be number of weeks. Alright, so how many periods do I have left? Well, this was after 5 years. Okay, she then decides to deposit an extra 500 every week into this account. Okay, the balance in this account after 5 years. So we've worked it out after owning this account for a total of 9 years. Mildred decides to close the account. Okay, so after 9 years, right? So obviously she's deposited for 5 years. So 9 minus 5 rather is 4. Okay, so 4 times 52 weeks in a year. Okay, solve for FV and you get 188,074,5029, which is option number 5. Okay, slightly off, 1 cent out. Okay, probably because of rounding, right? I haven't used rounding anywhere. Kept everything as is when I did the calculation. Okay guys, question 25. Alright, so here's a bond question. They want to know what the clean price is. Okay, so we know what clean price is. Remember, clean price is what? All in minus the accrued interest. Okay, so I've been given the all-in price. There's the all-in price. Okay, I'm just going to have to substitute all those values into my calculator and get an answer. Okay, so if you do that, your initial price, your all-in price, okay, after having substituted all of that in, remember that's your payment, that's your N, okay, not your N, that's your I, the 44 is your N, right, and I'm going to be solving. Okay, so all-in price, if you do that calculation on your calculator, okay, I get that. Alright, so that was the first, that's the all-in price of the first bit. Okay, so that's part one. So I've actually done this separately. I've added that together. Okay, then I've added that together. Right, so I'm going to show you both. Okay, it's that plus 15, 1988253. Okay, which you can actually do in one step if you want to. Doesn't matter how you get to the right answer as long as you get the 55,07,0752. Okay, I then need to work out the accrued interest. Okay, so final step. Okay, I get that answer, 50,41. Alright, okay, you'll see in this particular question, okay, we don't have an answer here for 50,41. Right, and the reason for that is if you look at this was divided by 5. Okay, and then you've got divide by 2 here. So is this half yearly or 5 times a year? Okay, it's very strange to have that, okay, as 10,4 divided by 5. Right, I'm assuming it should be divided by 2, not divided by 5, okay, because it's half yearly. Right, so there was a problem with this question. Okay, errata there, the answer isn't there. Alright, question 26. Okay, Sally wants to discharge debt 500,000 6 years from now using a sinking fund method. Okay, so as soon as you see sinking fund, you know there's two diagrams. Okay, the one for the savings and the one for the loan. Alright, so the first question is 26. 26 wants the monthly savings, okay, in terms of the sinking fund. Okay, so what are you going to be depositing to amortize this particular loan? Alright, the debt attracts interest at 15.6. and the sinking fund earns interest at 8.4. Okay, so the deposit is obviously the savings. How much do you want at the end? 500,000. Okay, so in 72, why 72? You'll see this was compounded monthly. Okay, so 6 years times 12 is 72 months. Right, if you solve for the payment, you get option number 2. Okay, question 27, the total yearly cost to discharge the debt. Okay, remember, if it's total yearly costs, it's your sinking fund deposits plus the interest payments. Okay, so how many deposits I'm going to be making? I'm going to be making 12 deposits. Okay, and those 12 deposits are of an amount of 5364.60. Okay, plus the interest that I must pay, which in this case was 15.6 paid quarterly. Okay, the debt 15.6. Four of them, so it'll be 4 times that, times the 500,000. Right, and if you work that on your calculator, you get an answer of 142. Okay, question 27's answer is option 5. Right, Hilton decides not to accept the offer from an insurance company or accident fund to receive 18,900 every 3 months indefinitely. Every 3 months is quarterly. He has to receive 2 payments, one 4 years from now and one twice the size 8 years from now. Okay, so these questions come up a lot. Okay, you're going to have to draw a timeline to show this calculation. Okay, so T0 is now. Okay, how do I get the 600,000? It's the present value of the 18,900 divided by a rate of 0.0315. Okay. $600,000. All right. Obviously, there's payments that we made here. Okay, so obviously take everything to the same point in time. Okay, so what I've chosen to do here is I've taken the x back and I've chosen to take the 2x back. Okay, so obviously those payouts, okay, need to amount to the amount that he was awarded. All right, so 600,000 is going to equal the x brackets Alright, the question said, how much is Hilton going to expect to receive 8 years from now, which is there. Okay, so to work out that amount, I want 2x. Okay, so final answer. is that? Okay, option number 3. 3, no, option number 4 actually. Okay, it's 888, not 885. Okay, 888. Okay. Alright, question 9 and question 30. The last two questions. Need to borrow 120 from Koos 4 years ago at 12.65 per year compounded quarterly. The amount plus interest is due 2 years from now. She also borrowed 65 6 years ago from Koos at a rate of 15.2 compounded monthly. The amount plus interest is due 2 years from now. Okay, so the total amount that Nita must pay Koos 2 years from now equals, okay, so best scenario here is to draw a timeline. Okay, so there's the one amount that's owed. Okay, what am I solving for? This. Okay, if I solve for future value, I'm going to get 2, 5, 3, 3, 4, 1, comma 2, 1, 0, 2. Right, and then I've got another loan. At a different rate. This was 6 months ago. Okay, and then just total these two amounts. Okay, and if you total those two amounts, question 29's answer is option number 4. Alright guys, and then last question, question 30. After seeing what she needed to pay K 2 years from now, N decides to reschedule her debt. She will pay K 85 now and the rest 5 years from now. K agrees on conditions that the new agreement will run from now and will be subject to 13.7% interest per year compounded half yearly. Alright, so again, what I need to do, I need to draw a little timeline to show what the actual picture looks like. Okay, so obviously I'm looking at T2 times 2. Okay, this was from FE from question 29. Okay, and the answer here was the loan amount, total loan amount. Total loan amount here is 34163, 1424. Alright, so what must I do? I need to take this amount back to time 0. Pay off a portion and then take it forward to time 5. Okay, so remember, money needs to be at the same point in time. Okay, so money currently is in the future, which I'm going to have to take back. I'm going to pay off a portion and then take the rest forward. Alright, so PV here, if you do it on the calculator, you get 267,106, 642, okay, less the 85,000 Rand payment, balances that amount. Okay, and then that amount is going to be taken forward to here. So PV equals that, N equals 10, I2 is 13.7%, divide by 2, solve for future value. And the future value I get here is 353,240,9555. Alright guys, and that's another past paper complete.